Section 12.9 discusses combinations. A combination is a distinct group or set of objects without regard to their arrangement. So this is different than a permutation. In a permutation, the order of the objects matter. For example, first place, second place, third place would be a permutation. A combination, you don't care what order the items are selected, you just care that you have a group of 3. So for example, determine whether the situation is a combination or a permutation. Option 1. A group of 5 friends, Arlene, Inez, Judy, Dan, and Eunice, are forming a club. The group will elect a president and a treasurer. How many different ways can the president and treasurer be selected? So in that situation, you have a president and you have a treasurer. They are 2 different roles, and therefore it matters which person you put in which role. Therefore, order matters, and since order matters, that would be a permutation. Number 2, of the 5 individuals named, 2 will be attending a meeting together. In how many different ways can they do so? So in this situation, you're selecting 2 people, but it doesn't matter who gets selected first or who gets selected second, so order does not matter. So in this situation, since order does not matter, that would be a combination. The combinations have a formula just like permutations do. The number of combinations possible when R objects are selected from N objects is found by, the way they write that is they write N combination R. In your numerator, you put N factorial. In the denominator, you have N minus R factorial times R factorial. You can also do this in your calculator. First, you hit the button that says Math. Then you need to go over to the probability menu. And then you scroll down to NCR. So let's look at an example. While visiting New York City, the Friedmans are interested in visiting 8 museums, but have time to visit only 3. In how many ways can the Friedmans select 3 of the 8 museums to visit? So in this situation, the order does not matter which one they see first, second, or third. All that matters is that they see 3 of the 8. So if you were doing this by hand, you would write 8 combination 3. In your numerator, you would have 8 factorial. In your denominator, you would have 8 minus 3 factorial times 3 factorial. So that would be 8 factorial divided by 5 factorial times 3 factorial. So again, if you're doing factorials by hand, remember that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. Now, the 5s can cancel, the 4s, 3s, 2s, and 1s can all reduce. So in your numerator, you have 8 times 7 times 6, and in your denominator, you have 3 times 2 times 1. So if you want, you can knock out the 1 because dividing by 1 doesn't do anything. Also, 3 times 2 is the same thing as 6, so the 6 in the bottom can cancel the 6 in the top. So you would have 8 times 7, or 56 different ways. I personally don't like to do it by hand. I prefer to do it with my calculator, so I'll show you how to do that. I have my calculator pulled up here for you. So if you're going to do this with your calculator, you hit the button on the left that says Math. You need to go over to the probability menu, which is you have to click over 1, 2, 3 times. And then you need to scroll down to option number 3 to get your combination. Now, I actually should have typed my 8 in first. So I'm going to get out of here, and I'm going to first type my 8. math, probability, NCR, and then 3. And the calculator will do it for you and give you the 56. Let's look at another example. Jan Funkhauser has 10 different cut flowers from which she will choose 6 to use in a floral arrangement. How many different ways can she do so? So again, the order of the flower selection doesn't matter. The flowers aren't ranked. They're all going to go in the same vase, so therefore this is a combination. So she needs to do 10 combination 6. So in the numerator, she'll do 10 factorial. In the denominator, she'll do 10 minus 6, or 4 factorial, times 6 factorial. And again, if you're doing this by hand, you would write it out. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all multiplied together. In the denominator, 4, 3, 2, 1, times 6, 5, 4, 3, 2, 1. So your 6, 5, 4, 3, 2, 1 will cancel. Dividing by 1 doesn't do anything. 3 times 2 is equal to 6. And 4 can go into 8 2 times. So if you are doing this by hand, you would take 10 times 9 times 2 times 7, which would give you 210. If you are doing this with your calculator, then you will simply first type in the 10, math, over to probability, down to option number 3, combination, and you are selecting 6 of the 10 flowers, and you'll also get 210. Okay, one last example. At the Royal Dynasty Chinese restaurant, dinners for 8 people consist of 3 items from column A, 4 items from column B, and 3 items from column C. If columns A, B, and C have 5, 7, and 6 items respectively, how many different dinner combinations are possible? So this one's actually a little bit tricky. You're going to have to do 3 separate combinations. One for column A, one for column B, and one for column C. And then you're going to have to multiply those combinations together. Okay, so let's look at column A first. It says that we get to select 3 items from column A, and that column A has 5 items in it. Again, order doesn't matter, so for that we'll have to do 5 combination 3. If you use your calculator, 5 combination 3 comes out to be 10. Then you have column B. You get 4 items from column B, and column B has 7 items in it, so you only need to do 7 combination 4, and I'm going to use my calculator to get 35. And then you need column C. Column C, you get to select 3 items, and column C has 6 items in it, so that would be 6 combination 3. If I use my calculator, that would give me 20. And then you need to know how many different combinations are possible, so you need to take 10 times 35 times 20. And there are 7,000 dinner combinations.